Okay, so in this next section, we're talking about line graphs. So yesterday we were talking about bar graphs and double bar graphs. Today we're going to be looking at the line graphs. So a line graph displays data using line segments. All right? And line graphs are a good way to display data that changes over time. So whereas bar graphs are probably used most often to compare categories of items, line graphs are most often used with things that change over time. So they go up and down. So here's how we look at these. So example 3, reading and interpreting a line graph. So we have the percent humidity, what percentage it is, and what time during the day. So use the graph to answer each question. At what time was the humidity the lowest? So in the blue it gives you a hint what to do. Well, at the lowest, you're going to look at the lowest points because it's measuring. So I look at the lowest points seem to be here, which looks like about 4 a.m. Okay? So 4 a.m. is the answer on that one. So I just look to see the points that are on the graph and read what it says. During which 4-hour time period did the humidity increase the most? So there's a couple things we're looking for. We're looking for a 4-hour time period, which makes sense because our intervals here are in 4 hours. 12 to 4, 4 to 8, 8 to 12, 12 to 4 again, 4 to 8, and 8 to 12. So the morning and the afternoon, or first half of the day into the second half of the day. And they're looking for the one that increases the most, which segment. So when they tell you that line graphs are made up of segments, each one of these is a line segment. So you're going to look for the one that has the greatest positive slope. So you know that if something is going uphill like this versus something is going uphill like this, this has a greater change, a greater rate of change. So if you're looking for one that has the greatest positive slope or increase the most, you would look for which of these increased the most. It kind of looks to me like this one increased more than this one. We're just eyeballing it, okay? So I would say from 12 p.m., I'll write it up here, to 4 p.m. And so what that means is that time of the day is the most humid. Change in humidity in that time of day, it increases the most. Then it kind of goes down from there. So that's how you read for those things. Now here, this is when we have to do a little bit of comparison. It says use the graph to estimate the difference in temperature between 4 a.m. and noon. So the first thing I'm going to say is here's noon and here's 4 a.m. Well, when they want us to find the difference means we have to see how much between the two, okay? And normally you're going to take one and subtract the other to find a difference. So first we have to say, well, what was the temperature at 4 a.m.? Well, the temperature was around about 60 degrees. And then what was the temperature at noon? It was around about 80 degrees. So now that I know that, that's a little bit over. You could call it like 62 if you wanted, 60 to 62 degrees. So when I say what's the difference, well, what's the difference between 60 degrees and 80 degrees? How far apart are they? You subtract. So the 80 minus 60 would be a 20% difference. If you wanted to be a little bit more precise and call that 18, you might have, call this 62, you might have an 18 degree difference or a 20 degree difference, okay? So you see how I picked that one out? Mm-hmm. Yeah. And then here, I would go with the 20 answer because of this word right here. You just round it, estimate it. They didn't ask for exact. All right. So just like we had a double bar graph, we have one also that is a double line graph. And that can be used to compare two related data sets change over time. So again, that's our key theme with line graphs is the change over time. So a double line graph has a key to distinguish between the two sets of data. So they'll always tell you in the key which one represents which. It might be that one is kind of represented like this, and it could be that one is represented like this. And that's how you tell the difference between the two sets of data. So here, one has dots and one has little diamonds. So we know one is blue, one is red. We have station A, we have station B, the months of the year, and the cost, and our title here is prices for regular gasoline. So we know that over the months, the price of gas is going up and down, let's say, and we're comparing one station with another station, maybe a Chevron and a Shell. So use the graph to answer each question. In which month did station A charge more than station B? Well, in which month, number one, is not plural, so I know I'm looking for just one month. So when I come over here, station A is in red, and when did they charge more? Well, it looks like station B is kind of ahead of the game the whole time, except where does the red go higher? Well, I notice on this line right here, the red is more than the blue. So that's the month that the red was, look, $1.28 a gallon, and station blue was $1.26 a gallon. And that month would be May, because they have them only listed by the first letter, but January, February, March, April, May. Okay? So your answer will be May. Okay, during which month or months, so here the difference, you see this one has a plural on it, so it may be one or more. Did the stations charge the same for gasoline? This one actually, I didn't take the answer out, so April and July. Let's take a look and see why April and July. I'm going to use a different color. So when I come up to April, they're both on the same dot right here. When I come up to July, they're both on the same dot right here. So you would be looking for where are they actually on the same place. And that's how you know that they cost the same. Because in April, they both cost $1.26, and then in July, they both cost $1.29, looks like. So you see where the data points overlap. Okay, here, use the graph to describe the general trend of the data. So I'm going to underline this right here where it says general trend. Because general trend, when you're looking for something generally, it's not as specific and detailed as math answers can be sometimes. So they're basically looking and seeing here airfare between two cities. So you have airline A and airline B represented by, let's call this teal and purple, and then how much it costs per month. So we'll see prices blank from January to July or August. So what do they do from January to July or August? Well, I'm going to mark here for January. This is where we're at. And then to like July or August, roundabout in this range. So if I kind of see where they're at, and I imagine, well, the general trend is that from here, this area to this area, it's kind of increasing. It's not increasing at a huge rate, but it is kind of creeping up slowly, even less than this. So I would say prices increased from January through July or August, okay? They went on an upswing. Prices kept going up. Then prices blank through November. So they decreased because here, from here to November, it's kind of a general trend going down. Now when we get to December, it's going to go up again, but they're only asking through November. So that's what they're asking. When they ask you to find a general trend, is it kind of going up? Is it going down? Is it pretty much staying the same across? That's a trend, okay? Just where it's going and where it's headed. And I think that's it. So that's all the information on line segments. We'll be using the bar graphs and the line graphs to put together our tally information with our questionnaires and decide. We're going to have to decide, one of the reasons we're using all these graphs and learning them, which graphs and graphic displays do we use to represent what questions on the questionnaire. Okay? Up next we have circle graphs.